Good day to everyone, and in this video we will see the sequence impedances for the transmission line. Okay, so transmission line, we will see the for the positive, negative and zero sequence impedance for the transmission line or the network, you can say. Okay, so sequence networks. Okay, so in this video we'll see the sequence networks for the transmission line. So see, now I will be only discussing what is essential to you for you to remember. Okay, for derivations you can refer standard books, but for solving questions this video will be enough. Okay, so what should be your understanding? See if there is a line, okay, three-phase line. Okay, so in three-phase line, your the impedance of the line is given by ZAA, ZBB, and this is ZCC. Okay, so these are your three-phase lines with given impedances, and let us say this is your reference. Okay, or you can say a neutral line. Okay, so this will be your VA, that is I am writing the phase voltage. This will be your VB, and this will be your VC. Okay, now this for these are VA, VB, VC for this side, and for this side it will be VA dash, VB dash, and VC dash. Okay, so you can mark the line in this fashion. C dash. Okay, so now there is one thing, ZAA, ZBB, ZCC, and there is also one more thing, that is ZAB, or you can say as mutual impedance. Okay, so see, this will be your ZAB. See, what is the meaning of ZAB? That is the impedance of A due to B. Okay, so due to the current flowing in the B, it will have some effect on the this conductor of A phase. Okay, so this term is known as mutual impedance. Similarly, you have this ZBC and you have this ZCA. Okay, so these are the three impedances. Now the thing is, see, now your ZA, ZBB, ZCC are known as what? These are known as the self impedances. Okay, and ZAB. Okay, so you have to remember this circuit and these things. Okay, else you will always confuse. Okay, ZBC, and this is ZCA. So these are called the mutual impedances. Mutual impedances. So ZAB means that is the impedance of A due to B. Okay, so that is the thing. So okay, so now we have I hope you know this, but see, for the symmetrical lines, your LA is equal to LB, that is the inductance of each line of phase. Each phase line is same, but for asymmetrical line, your LA is not equal to LB, not equal to LC. So to make the symmetrical line what we do, we transpose the three-phase lines. Okay, so this is the concept that we use. So when you transpose, what happens is, Okay, so we will see that for transposed line. Okay, so we always consider the transposed line by default in our syllabus. Okay, because this is desirable. We always want the equal impedance of each line. Okay, so that is why we do this fashion. Okay, so for transposed line, your ZA is equal to ZBB is equal to ZCC is equal to Zs. Okay, so this we can keep equal for untransposed line also, but the thing comes when your system is symmetrical. Okay, so in that case your mutual impedances will not be equal. So by transposing we make those mutual impedances equal. So for the transposed line, your ZAB is equal to ZBC is equal to ZCA and is denoted by Zm. Okay, so this is the our main basic point of interest. You should always remember what is Zs, what is Zm, and what is the feeling by this diagram. Okay, so that is the thing that should be in your mind always. So for transpose line, these are the things. Okay, so now there is a derivation, but I won't go in the derivation. I will just give you the results, and you should always remember these results, and you should be able to analyze that what you can infer. See, so for the transmission line, the positive sequence network is given by your Z1 is equal to Zs minus Zm. Okay, and your positive sequence impedance is given by Z1 and it is equal to Zs minus Zm. So you can draw it in this fashion. That is, this is your VA1, this is your VA1 dash, and this is your Z1 is equal to Zs minus Zm. Okay, so this is a positive sequence network, and you can draw the negative sequence network in this fashion. Okay, so this will be your VA2, this will be your VA2 dash, and this will be your Z2. Z2 is equal to Zs minus Zm. Okay, so and your zero sequence network will be this will be your VA0, this will be your VA0 dash, and this will be your ZS plus 2Zm. This will be your Z0. Okay, so our zero sequence network impedance is Zs plus 2Z. So you can write the matrix in matrix form. You can write in this fashion. Your positive sequence was Zs minus Zm. Okay, so it depends. Okay, so it depends whether in which KVL pattern you are writing. Okay, so what I mean to say is that if you are writing in this fashion, that is delta V A0, delta V A1, delta V A2. Okay, that is a voltage drop in all the three sequence networks. What is delta VA0? That is VA1 dash minus VA1. Okay, or VA1 minus VA1 dash. Okay, so your delta VA0, this is equal to, and this is a matrix, is equal to a matrix which your zero sequence impedance is Zs plus 2Zm. Your positive sequence for delta VA1 is Zs minus Zm, and this is also Zs minus Zm. Okay, so this matrix we arrive after a cool derivation, which I have skipped in this video. If you are not getting it from book, then you can ask on our website in the doubt solving section. Okay, so yeah, so this is the matrix. So it's a KVL only, and it will be divided by your currents, and your currents will be what? IA0, IA1, IA2. Okay, So what you need to remember is that your positive and negative sequence impedance for a transmission line is same. So that is the first understanding that you have to take. And your Z naught is what is Zs plus 2Zm. Okay, so that you should remember. So what is the positive sequence impedance for the transmission line? Zs minus Zm. It is equal to the negative sequence impedance, and your zero sequence impedance is given by Zs plus 2Zm. So you should remember these three formulas for most of the questions. Okay, so that is the most important thing in this video. Okay, so I hope you get the idea. And see, one thing is also there, that see, if in a question you want to identify by, if in a question you are given the sequence impedances, and you want to identify that whether it is of transmission line or not, so what you will check? Okay, so if given the sequence impedances and you need to check whether they are of transmission line. So what you will do, you will check for these things. A part, that is your Z1 should be equal to Z2, that is a positive sequence impedance should be equal to negative sequence impedance, because it is Zs minus Zm only. Okay, and your second part will be, okay, just remember this thing, that your zero sequence impedance is approximately equal to 3 times Z1. Okay, so this you can remember. So these are the things that you should keep in your mind, and you will solve almost every question of the related to the transmission line zero sequence things. Okay, so that is the overall discussion. So I hope you get this. Thank you. Please like, share and subscribe Electrical Diaries, and visit our website for more, and you can practice there the previous year questions and many things. Okay, thanks a lot.